Don't forget to subscribe and ring that bell.
All aboard. The train is moving. We finished question 1 and 2. Now we are on to free response question number 3 of the 2019 AP Calculus AB exam. No calculator, but meh, who cares? You know we got this. So let's go out there and just kill it, people, shall we? Let's begin. Number 3. Oh, I love me graphs and charts and tables. Oh my. We have a graph here. I'm just getting excited. Number 3 reads, the continuous function f is defined on the closed interval from -6 to 5 inclusive. The figure above shows a portion of the graph of f consisting of 2 line segments and a quarter of a circle centered at the point 5, 3. It is known that the point 3, 3 minus radical 5, is on the graph of f. So let's just do a few things here, shall we? The center of the circle, okay, be nice, there we go, is right there at 5, 3. And for some odd reason, it gives us this point. The x value is 3 and the y value right here is 3 minus the square root of 5. That's probably going to come in handy at some point. Let's see what a is telling us. If the integral from -6 to 5 of f of x dx equals 7, find the value of the integral from -6 to -2 of f of x dx and show the work that leads to your answer. All right, what I am going to do here is I'm going to take this up. Yep, no, undo that. Got to turn it into the end. Let's bring this down here because I like to show you something, kids. Now, they're giving me, okay, they're giving me the integral, the area under the curve from -6 to 5, okay? Well, here's where 5 is. -6, if I could, would be way out here, okay? So they're giving me, and I don't know what this looks like. I don't know, whatever it looks like. They are giving me the area, okay, under the curve of everything from -6 to 5. They're asking me to find from -2 to -6. So they want me to just figure out what it is from here. All right? So if I'm thinking about this correctly, and I think I am, okay, I'm going to take the integral from the whole thing, from here all the way to here. That's 7. And I'm going to subtract the integration from here to here, this area under the curve. If I take this away, that will leave me with what I need. Okay? So really, I need the integration from -6 to -5 of f of x dx. And I'm going to subtract away the integration from -2 to 5 f of x dx. Okay? And that should give me, that would leave me the integration from -6 to -2 of f of x dx. So this is really, it's really just a fancy way of saying find the integration of this. This is all we got to find because we're given this. This is 7. We just got to find out what this value is and just subtract it from 7. So let's erase all this fancy stuff we drew. And we're going to do some work here. All right. So the area under the curve from -7, excuse me, from -2 to 5. Okay, so this. Okay. I'm going to do something. I'm going to change this up. And there's this and this. Then we have this in green. I'm using these different highlights for a reason. and then all this in yellow. Okay, so I just got to figure out what that is and subtract it from 7. And the reason I use these different colors is as follows. All right, you should know at this point everything above the x-axis is considered a positive area, and everything below the x-axis is negative. If I look at the area of this triangle, this is a 1 by 1 triangle, but that's positive. This is a 1 by 1 triangle, but it's negative. These areas are the same. It's 1/2. It's a positive 1/2 and negative 1/2. So they're going to cancel. If you want to write it, you can. Positive 1/2, negative 1/2, but they cancel. Also, this triangle right here is 1 tall by 1/2 wide. Okay, so it's 1/2 base times height. That's actually negative 1/4 right here. This triangle is positive 1/4. It's the same. So these are all going to cancel. These are all going to cancel out. So really, I just need to find out what's left. That area right there. So let's figure it out, shall we? The area, this is a trapezoid, first of all. This is a trapezoid. This base is 1. This base is 3. And the height is 1. So the area of a trapezoid is 1/2 base 1 plus base 1, 2 times the height. All right, 1/2 1. So that's going to give me 2. The area of this is 2. All right. So these are all bye-bye. We have 2. I got to add the area of this like wedge. Here's the thing. Okay, here's the thing. This wedge right here. This wedge. What I'm going to do is I'm going to find the area of this. Is that a rectangle or a square? That's a 3 by 3 square. And I'm going to subtract the area of the quarter circle from it. That's really all I can do. The square is 3 by 3. So that's 9. But I got to subtract pi r squared. It's 1/4 pi r squared. 1/4 pi r squared. My radius is 3. So that's 9 pi over 4. Sorry about my sloppy writing here. So we're looking good. All right. All I've got to do is do my math at this point. Okay, it's 7. I'm going to just distribute this. Minus 2 minus 9 plus 9 pi over 4. 7 minus 11 is negative 4. So I end up with 9 pi over 4 minus 4. That's what this equals. That's what happens when I take 7 and subtract this. There you go. All right, there was a lot of explanation in 3a. Let's take a look at what 3b says to us. We evaluate the integral from 3 to 5 of 2 times f prime of x plus 4 dx. All right, well, first off, if I'm integrating, I'm just going to integrate right down the line. So I'm basically going to take the integration from 3 to 5 of 2f prime of x dx. Okay, that's this part. Then I'm going to add that to the integration from 3 to 5 of 4 dx. That's this part. All right? And here, I'm going to take this 2, it's a constant, and move it outside. Ooh, wow, that's a big one. Oop, let's do the small one. There you go. And I hope you remember one of our most basic rules of integrals. When I integrate the derivative, it gives me the original function. So this is going to be my original function with the top bound minus my original function with the bottom bound. And oh, let's not forget, we still got to multiply it times our 2. I'm going to add that. Okay, when I integrate 4, that gives me 4x. And I want that from 3 to 5, which means I put my top bound in and I subtract my bottom bound. Okay, this isn't too bad yet. Let's go to our graph of f and see what these things are. All right. When f is 5, remember, these are just coordinates. When I have an x, what's the y right here? The y is 0. So f of 5 is 0 minus, here we go. I knew this would come into play. What's f of 3? When x is 3, what's the y? That's where this right here comes into play. When x is 3, my y is 3 minus the square root of 5. I knew that was just way too weird to be given to us for nothing. 3 minus the square root of 5. Subtracting 3 minus the square root of 5. And then I'm adding that to all this junk. And oh, by the way, let's not forget, we still got to multiply this by 2. This is negative 3 plus the square root of 5. I still got to multiply both of those by 2. So I've got negative 6 plus 2 radical 5 plus 20 minus 12. I mean, I can combine some things here. I can take 20 minus 12, that's 8, minus 6, that leaves me 2. And I still have my plus 2 radical 5. And we are done, man. Okay, I see something that is probably going to be very common on an AP exam. C reads, the function g is given by g of x, which is the integral from negative 2 to x of f of t dt. Find the absolute maximum value on g on the interval from negative 2 to 5. Okay, this is good because we have negative 2 to 5 right here. Now, when it says the absolute minimum value, my maximum value, that's going to be a coordinate. They want the max value. They want the y. The x is the location where the maximum occurs. The y is the actual maximum value. So when I find where this maximum occurs, when I find the x, I need to go back and find the y. So, first things first, in order to find any min or max, we need to find where our critical points are, where our derivative is 0. So let's find the derivative of g. Okay? And when I say this is very common, you're going to see this a lot. If I want to take the derivative of g, I got to take the derivative of an integral. This is very common. Negative 2 to x of f of t dt. Now, derivatives and integrals kind of cancel. The dummy variable goes away with the integral. As long as the bottom is a constant and the top is just an x, that's just going to become f of x. So the derivative of g is my graph, f of x. So let's figure out where this is equal to 0. What values of x? All right, well, I see it's equal to 0 here at 5. It's equal to 0 here at negative 1. And it's equal to 0 here. Now, if y, now pay attention here. If y is f, my function, and that's also g prime, okay? The y coordinate of all of these points represents g prime. So anytime I'm above the x-axis, I have a positive derivative or slope for g. And anytime I'm below the x-axis, I have a negative slope for g. So look, I'm starting at -2 and I'm going up. So -2 cannot be a maximum. You're starting here and your slope is going up. Then my slope goes down just a little bit. So maybe it goes down just a little bit. And it hits this point, which might be like 1/2. But then look, it continues to go up and up and up and up and up and up until it hits an x value of 5. So it goes up and up and up. I'm thinking the max is going to be right here. Okay? We don't have to check 1/2 here, where this is 1/2. We don't have to check this. This is a minimum. They're asking for maximums. The only one we got to check is at 1 and at 5. All right? So what I'm going to do to make sure we have the highest of high, because I need the absolute, so I'm going to create a little table here for -1 and 5. All right? So how do I find this spot right here? Well, g of -1, I've got to use the equation they gave me. I got to find the area under the curve from -2 to -1 of f of t dt. All right? So if I go back up here, I want to find the area under the curve from -1 to -2. I basically just got to find from -1 to -2. This half a triangle. 1/2 base times height. Okay? The base and height are 1. So that's 1/2 times 1 times 1, which is 1/2. So this has a maximum height of 1/2. This part right here is the integration from -2 to 5, f of t. And this should look familiar to you because we already found that. This is g of 5. We already found that in part A. Didn't we have to subtract? Oh, I love the highlighters. Didn't we have to subtract this? That's what we're looking for right there. That's this value right here. 9 plus 2 is 11 minus 9 pi over 4. We have that already. So I'm going to go back here, and I'm going to say this is 11 minus 9 pi over 4. That is bigger than 1/2. And now I have found my absolute maximum value, and there it is. All right. Okay, 3D. On to the last one. Find the limit as x approaches 1 of 10 raised to the x minus 3 times f prime of x over f of x minus arctan of x. Boy, you should know what arctan means. Not only that, you should know what the arctan of 1 is. We'll get there in a second. Okay. So just like any limit, we're going to start by plugging in our value. And what do I mean? I'm going to take this 1 and plug it in for every x here. That's what we're going to start out doing. So we have 10 to the 1 minus 3 times the derivative of f at 1 all over f of 1 minus arc tan of 1. This is the same thing as saying tan -1 of 1. Maybe that looks a little bit more familiar to you. All right, well, let's start evaluating this. 10 to the 1 is just, I'll do this up here, it's just 10. Minus 3 times, this is telling me I want the slope at 1. If I look at here on my graph, what's the slope of this line? That is up 2 over 1. Up 2 over 1. That has a slope of 2. That is 10 minus 6, which is 4. All right. F of 1 is just asking me for the y coordinate when x is 1. When x is 1, y is 1. That's the coordinate 1, 1. Okay? So this is 1 minus, oh, guys, here we are. Knowing what the arctan is, that's just basically saying what radian or degree, if you take the tangent of it, would result in 1. Okay? The tangent of 45 degrees is 1. So the arctan of 1 is 45. We don't use degrees in the calculus test. We use radians. So it's pi over 4. You need to know that, just like you need to know the ln, or natural log of e, is 1. Okay? Just like anything to the power of 0 is 1. Just like you need to know that the sine of pi, or 180, is 0. These are just basic things you need to know. So this is pi over 4. You don't have a calculator, so leave it. 1 minus pi over 4. And that's it. There's your answer. That's the limit as x approaches 1. And guess what, kids? We're done. I'll see you for problem number 4. Bye-bye.
Don't forget to subscribe and ring that bell.